Hello everyone and welcome to my thesis presentation. The title of my research is Enhancing User Experience in Monstack Application Using Progressive Web Apps. This study explores how progressive web app features can be integrated into Mon-based applications to improve performance, user engagement, and reliability. My name is Christian Pejol D'Souza and I'm excited to share the findings and insights from the project with you. Let's help begin by understanding the project. Web application today face the challenges of meeting rising user expectations such as fast load times, offline access, and mobile responsiveness. Progressive web apps or PWAs are designed to combine the best of web and mobile apps, offering speed, offline capabilities, and installation on the home screen. Meanwhile, the MERN stack, MongoDB, Express.js, React, and Node.js is widely used for building scalable web applications. This research aims to merge both technologies and investigate whether this combination results in better user experience. Next is problem statement. One of the major challenges with modern web application is maintaining high performance and consistent user experience, especially in environments with poor connectivity. Despite their growing capabilities, many traditional web apps still lack offline support, perform inconsistency on slower network, and don't actively re-engage users once they leave the platform. This research explores the critical question: how can integrating progressive web app features into a monster application enhance user experience? Need for performance improvement, offline support, and re-engagement capabilities in web apps. Next is research objectives. The primary aim of this research was to enhance the user experience in web application by combining the Monstack with progressive web app feature. To achieve this, I have set three key objectives. First is to develop a robust food ordering application using the Monstack, which includes MongoDB, Express.js, React, and Node.js. This app called Foodigo forms the base of the study. Second, to integrate core PWA capabilities such as service workers for offline support, a web app manifest for installability, and push notification using Fireplace cloud messaging. This features helps the web app function more like a native app. And third, to evaluate performance and user experience improvements through a mix of performance testing tools such as Lighthouse and web-based test along with direct user feedback collected via surveys. Together, this objective guided the implementation and analysis process for the entire project. Next slide. Here we can see the heading as literature reviews for PWA, Progressive Web Apps. PWAs are web applications that provide an app-like experience while using standard web technologies like HTML, CSS, and JavaScript. The main goal is to combine the reach of the web with the functionality of native apps. A key component of the service is the service worker which runs in the background to handle caching and network requests. This allows PWA to function offline or on poor connection, improving reliability. Another powerful feature is push notifications. These are used to re-engage users with real-time updates or reminders, just like native mobile apps, which enhances user retention. However, there are still some challenges. This includes managing cache updates, ensuring consistent support across all browsers, and addressing SEO issues. SEO means search engine optimization. Since much of the content here is loaded dynamically using JavaScript, we face these issues. Despite these challenges, PWA shows strong potential for improving performance and user experience in web application. Next comes literature review in Monstack. In this section, I will briefly explain the Monstack technologies that form the foundation of modern web applications. Starting with MongoDB, it's a flexible NoSQL database that allows us to store data in JSON-like documents. This makes it highly adaptable for unstructured or evolving data, perfect for fast-moving application development. Next, we have Express and Node.js. Together, they form the backend engine. The node provides a fast and event-driven runtime while Express simplifies routing, middleware, and server-side logic. This combination allows for a robust and scalable backend architecture. On the front end, we have React, which plays a critical role in enabling the creation of dynamic component-based interfaces and supports a single-page application model. Overall, the merged stack is ideal for building scalable, modular web application with full-stack JavaScript, ensuring efficiency across both front-end and back-end. Next comes the methodology overview. This slide presents a high-level overview of the research methodology, which was structured in four key phases to ensure a systematic investigation of PWA integration into a monster application. In phase 1, I conducted a thorough literature review and problem analysis. This involved studying existing research on PWAs and Monstack to identify gaps, particularly around performance, offline functionality, and user engagement. Phase 2 involved actual development of the Monstack application using MongoDB, Express, React, and Node.js. This formed the foundation for experimentation and was designed with scalability and modularity in mind. In phase 3, I integrated progressive web app features like service workers, app shell architecture, web manifest, and file-based cloud messaging into the MERN app to enhance offline access, speed, and engagement. Finally, the phase 4 consisted of testing and evaluation. This included performance analysis with Lighthouse user surveys to access experiments experience and accessibility and browser compatibility test to ensure consistency. Next is MERN app implementation. In this phase, I developed a core application titled Foodigo, a full-stack food ordering platform built using the MERN apps. This app included key features such as user authentication, dynamic food listing, a shopping cart, a complete order processing system, and an admin panel to manage food items, stock, and orders. On the backend, I used Express.js to create RESTful APIs and connected them to MongoDB, which handles all the database operation. Node.js powers the server logic and efficiently handles asynchronous requests, making the backend scalable and responsive. The front end was built with React, offering a dynamic and smooth user interface, including route-based rendering and stateful components for real-time updates, especially useful in the cart and order flow. Next, once the core MERN app was complete, I moved into the progressive web app integration phase. First, I implemented the web app manifest, which defines how the app appears when installed on a user device. This includes icons, display mode, app name, and background color, allowing users to install the app to their home screen like a native mobile app. Next, I configured service workers, which are crucial for offline capabilities. They intercept network requests and serve cache resources when the device is offline or has poor connectivity. This means user can still browse previously loaded pages and complete certain actions without internet access. Finally, I integrated push notification using Firebase Cloud Messaging (FCM). This allows real-time communication with users like order updates or promotional messages even when the app isn't open. It enhances user engagement and encourages repeat visits. Overall, this PWA enhancement brought native-like performance, better reliability, and improved engagement in my Foodigo app. Next is testing and tools. After integrating the PWA features, I conducted thorough testing using a combination of performance, functionality, and user evaluation tools. For performance testing, I used Lighthouse and web page test. These tools help analyze key metrics like load speed, time to interactive, and PWA compliance. The result confirmed improvements in speed and responsiveness compared to the original MERN version. To test offline functionality, I inspected IndexedDB and cache storages in the browser. This ensured that the resources were being cached correctly and users could interact with the app even when disconnected from the internet. I also ran a user feedback survey to evaluate real-world usability. This focused on ease of use, pursuit speed, and overall experience, allowing me to gather qualitative insights directly from the users. users. Finally, for SEO testing, I used Google Page Speed Insights. This allowed me to evaluate how well the app was optimized for search engine, which is especially important given the heavy use of client-side rendering in React. Mhm. Slide 11. This is the performance matrix. Uh, let's look at the performance results after integrating the PWA features into the burn-based Fudigo app. Firstly, the page load time was reduced by approximately 40%. This was achieved to catching via service workers and the use of app shell architecture, which ensured faster initial content delivery. Next, the Lighthouse PWS code improved significantly from 49 to 91. This improvement reflects better progressive enhancement, faster load speed, offline functionality, and mobile responsiveness, all critical indicators for a successful PWA. Lastly, the offline access was tested successfully across multiple devices, including desktop and mobile browsers. Next is the user experience. Now let's review the user experience results gathered through surveys and feedbacks. According to the survey I conducted, 85% of the users rated the app as noticeably faster compared to traditional web apps. This highlights the performance benefits brought by the PWA features like catching and optimized loading. Additionally, 70% of users found offline support particularly useful, especially when they had intermittent or no internet connectivity. This offline capability ensured uninterrupted access to key app functionalities, improving overall satisfaction. Furthermore, the integration of push notification led to a 25% increase in user engagement. User reported that timely notification of order updates and promotion helped them stay connected and encouraged them to revisit the app more frequently. Overall, this user feedback metrics validate that the PW announcement have made a positive impact on both usability and engagement. Now, in this discussion, we reflect on the overall impact of integrating progressive web app features into the Monstack application. The PWA integration significantly enhanced the app's performance and accessibility by leveraging service workers for catching and offline access. The app loads faster and remains functional even without network connectivity, which is a major advantage for users on the go or with unreliable internet. Another key benefit was the real-time feedback loop enabled by push notification. This notification helped maintain active user engagement by providing timely updates and promotional messages directly to the user's device. However, the implementing caching strategies required careful planning to avoid stale content issues. Improper cache management could lead to users seeing outdated information, which can degrade user experience and trust. Therefore, the cache invalidation and update logic had to be designed thoughtfully to balance performance with data freshness. Challenges encountered during this stage. During the development and integration of PWA features, there were several challenges. Firstly, managing push notification was complex. Many users hesitate to grant notification permission, so the app needed to request them tactfully without disrupting the user experience. Secondly, cross browser PWA behavior differences presented more hurdles. Different browsers have varying levels of support and subtle differences in how service workers and manifest files are handled, require extensive testing and browser specific adjustment. Third, cache invalidation and data synchronization complexities proved challenging, ensuring that the data app displays the most up-to-date content while still benefiting from caching required sophisticated strategies to synchronize data effectively, especially when users went offline and came back online. Slide 15. Okay, this is the conclusion. To conclude this, the integration of the progressive web apps features significantly enhanced overall performance, user experience, and engagement of the Monster application. The Fodigo app now performs reliably even in low connectivity or intermittent network conditions thanks to service workers enabling offline functionality and smart caching. This project successfully demonstrated the feasibility and practical benefits of PWA from the features when integrated into the real-world application built with the MERN stack, confirming that PWS can bridge the gap between web and native apps. Contribution. This research made several key contributions. Firstly, it provided first-hand implementation experience of integrating PWA capabilities within a Monstack application, which is valuable for developers exploring this modern approach. Secondly, the project evaluated the real-time benefits of offline support and push notification through both technical testing and user surveys, offering quantitative and qualitative insight. Finally, the survey-driven insights provided user-driven feedback on UX improvement, validating that PWA features can positively impact user satisfaction and engagement in practical scenarios. Future work. Looking ahead, several um, avenues for future work can be identified. One promising direction is to explore AI-based catching and personalization, where machine learning can optimize what content to catch and preload based on user behavior patterns. Another important feature to implement is background sync and predictive loading, which would further improve offline data synchronization and reduce perceived load times. Finally, extending this research to evaluate PWA integration across different industries, app types, and alternative technology frameworks will provide a broader understanding of PWA's benefits and challenges in diverse contexts. Thank you for listening. This concludes my presentation on enhancing user experience in Mustang application through PWA features. I hope this study has provided valuable insights into practical benefits of modern web technologies. Thank you.